Okay, so now we're going to have a look at another question from waves and thermodynamics. This is a question about light waves. So we are told a ray of light traveling in air enters a diamond at an angle of 10 degrees to the normal. We're asked A, what is the angle of refraction in the diamond? And then we're asked B, what is the angle to the normal required for total internal reflection? So these questions are a little bit different. So we'll start with A. We'll deal with A first, and then we'll define what is meant by total internal reflection, and then we'll work out what to do with B. So we'll draw a diagram here. This is the diamond. This is diamond. This is the air. So the light comes in at 10 degrees to the normal. Well, normal is perpendicular to the surface. So 10 degrees to the normal looks like this. This is 10 degrees in here. And then when this moves into the diamond, it will generate an angle like this that has some angle which we'll call theta 2. So theta 1, which is the angle to the normal when the light hits the diamond, you'll then get a change of direction of the light vector, and we'll get a new angle which is called theta 2. Now for this question, we need to know a little bit about air, and we need to know a little bit about diamond. So we need to know the indices of refraction. So for air, our associated index is typically considered to be 1. So we say n is equal to 1 for air, and this has a few different names, but we're just going to be calling it index of refraction. Now diamond's index of refraction is about 2.4. And you'll sometimes see this as 2.2, sometimes 2.5. These numbers can vary a little bit. It depends specifically what you're talking about when you say diamond. But we are going to say that air is 1, diamond is 2.4. So here we're going to be using Snell's law. So N1 times sine of theta 1 is equal to N2 times sine of theta 2. So this is our main rule for this question. So we know N1 is 1, N2 is 2.4, theta 1 is 10 degrees, theta 2 is unknown. So let's plug everything in. We get 1 times sine of 10 degrees is equal to 2.4 times sine of theta 2 degrees. And in the question it says, what is the angle of refraction in the diamond? Well, this is actually theta 2. So we're just trying to find theta 2 here. So divide both sides by 2.4. This cancels this. We have sine theta is sine of 10 over 2.4. We're now going to apply the arc sine to both sides. So we'll get theta is arc sine of 10 on 2.4. And now we can put this in our calculator and generate a decimal approximation for this. So we're going to have shift sine, which is arc sine, of the fraction sine of 10 degrees divided by 2.4. My calculator tells me that this is 4.1491, 4.1491 ... and that is in degrees. So the angle of refraction in the diamond is about 4.14 degrees. And this is the answer to our first question. Now part B is somewhat more complicated. We're told what is the angle to the normal required for total internal reflection. So this is a very strange question in this context, because if we look at our diagram, we have air over here, we have diamond over here, we have a normal vector this way and a normal vector this way. We have the ray hitting with an incidence angle θ1, then we have the ray leaving with incidence angle θ2, and these θ1 and θ2 look equal here. They're not necessarily. This diagram is not to scale, it's just used to represent what's going on. We have n equals 1 here, and we have n equals 2.4 here. Now, total internal reflection means that θ2 is equal to 90 degrees. It means that the light comes in this way and then reflects through the surface. And so total internal reflection is such that θ2 must be equal to 90. Now, this is just what this means. This is what this means in real terms. The light comes in and then just reflects internally within the surface, so no ray leaves. And what that means in terms of the mathematics that we're doing is that the θ2 has to be equal to 90. So if we plug everything in, we get 1 times sine of theta is equal to 2.4 times sine of 90. Now, sine of 90, this is actually equal to 1, because the sine curve does this. This is 90 degrees, this is 1. So this implies sine of theta must be equal to 2.4. Well, actually, this is impossible. This can't happen, because sine theta is bounded by +1 on the upper end and -1 on the lower end. What this means is there is no possible angle. So therefore, there is no angle which will cause total internal reflection. And this is actually an answer. This seems like a very unusual answer, because when students take these courses, they usually start to think in terms of what numbers do I put into what equations to get what answer. Well, sometimes things are not possible. Right? Sometimes you will be working on a particular question, and the question will seem to have no possible answer. These types of questions, it's certainly in subjects like chemistry and physics and things like that, if you get a question like this, the teacher wants you to think about the physics. They don't want you to think about the calculation. Right? They want you to do the calculation fails, and then they want you to think, is this possible? Right? Is it possible that the fact that the calculation has failed means that that this is not possible? And in this case it does. The reason being that if you have two surfaces, let's say n is 1 and n is 2, you will get a bigger angle here and a smaller angle here. So θ1 and θ2, in this case, θ2 will be less than θ1. If you have the opposite of this, if you have n is 2 over here and n is 1 over here, you'll have a smaller angle here, θ1, generating a bigger angle over here, θ2. So in this case, θ1 will be less than θ2. So in the case where we are moving from a lower refractive index to a higher refractive index, it may be impossible to get total internal reflection. But when we are moving from a higher index to a lower index, then it is possible to get total internal reflection. So in this case, the answer is there's no angle which will cause total internal reflection.